Tennessee's At Home Learning series for math. Today's lesson is for all our 6th graders out there. All children are welcome to tune in. This is the 3rd in our series. My name is Reggie Cruz and I'm an assistant principal and former math teacher in Tennessee schools. I'm so excited to be your virtual teacher today for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find it on Tennessee Department of Education website at www.tn.gov/education. You can still tune in to today's lesson if you haven't seen the others, but it may be more fun if you go back and look at the previous lessons, since our lessons today will be talking about some stuff that we previously learned. Today we'll be learning about using the distributive property to write equivalent expression in mathematics. Before we get started, to participate fully in our lesson today, you will need the following: paper and pencil. Got that? Let's begin. Students, find a piece of paper or print off the problems. We're going to work on applying the properties of operations to generate equivalent expressions. We'll start with a review to begin engaging our brains. So what properties of operations have you worked with before? Again, I want you to think about what properties of operations have you worked with before? You're right, commutative, associative, and distributive. Today we're going to focus on using the distributive property to show equivalent expressions. Let's start with creating a model. For the first example, we're going to try using a tape diagram. So I want you to create a model for 2 times 5. So using a tape diagram, hopefully, it looks like this. All right, so now, knowing how to use a tape diagram, we're going to create a model for 2 times b, or 2b. So 2 times b, or 2b. Using what we previously used, now use this, see if you can create your model. So hopefully your model looks like this. You've been creating models for expressions for several years. So today we're going to be using those models to show equivalent expressions. Keyword equivalent. So let me erase my board. All right, so we're going to write an expression that is equivalent to 2 times a plus b. And I'm actually going to use a capital A because my A's look like a 2. So 2 times a plus b. In this example, we have been given the factored form of the expression. So to answer this question, we can create a model to represent 2 times a plus b. Let's start by creating a model represented in 2a. So we're going to start here. And the reason why we're starting here, think about our previous lessons that we've done. So my model I have which this model represents a plus b. Go ahead and write that down. So now I need my model to show 2 times that amount. So the expression 2 times a plus b tells us that we have 2 of the a's plus b. So using this tape diagram, let's continue to build on this model to show 2 groups of a plus b. I have 1 group of a plus b, so to show that, I'm going to create another group of a plus b. So A plus B. A plus B. So the expression 2 times A plus B tells us that we have 2 of the A plus B's. Again, how many A's and how many B's do you see in this diagram? Correct. I see 2 A's and 2 B's in this diagram. So how could we use this model, or how should we regroup this model to make it reflect that? So I can group all my A's together and all my B's together. So how about we try this? Let me move my B here. And then I'm going to move my A here. So I have rearranged my model. So now this represents what? This represents 2A, and this represents 2B. So now I can write this based off of this, is I know that this is 2A plus 2B. So that is my equivalent expression to this. 2A plus 2B is equivalent to that. What conclusions can we draw from the models about the expressions? Well, one conclusion is that we know that they're now equivalent. So I know, again, that 2A plus 2B is equivalent or equal to 2 times A plus B. Good job. So I want us to prove this stuff. So I know, let me erase my model so we can prove. So I just said that 2A, 2 times A plus B, is equal to 2A plus 2B. We're going to prove this. So looking at this, what are some values that we can use to plug in to substitute A and B to see if this works? Great idea. Let's use A equals 3. So A equals 3 and B equals 4. So now I'm going to plug in. So I know that I have 2 times, I'm going to replace A with 3 and B with 4. Same thing here, I have 2, replace A with 3, plus 2, replace B with 4. Remember, in our order of operations, I'm going to solve inside of my parentheses first. So 4 plus 3 is going to give me 7. So that's going to be 2 times 7. Same thing here, multiplication left to right. So 2 times 3 is going to give me 6, plus 2 times 4, which is going to give me 8. Now I can finish solving both. 2 times 7 is going to give me 14. 8 plus 6 is going to give me 14. Do I get the same answer on both sides? Yes. So this proves that these expressions are equivalent to each other. Let's look at another problem. So, knowing this, using what we just previously learned, I want to write an expression that is equivalent to the double of 3x plus 4y. So I'm going to write an expression that's equivalent to the double of 3x plus 4y. What does it mean to double? I want you to think about that. When I say double something, what does it mean to double? Yes, double means multiply by 2. So what it's really asking for us to find is an expression that is equivalent to 2 times 3x plus 4y. So I'm going to write that down. So good to know that I know when I see that that means double. So let's draw a model. Again, knowing going from our order of operations, we're going to draw a model to represent the inside of our parentheses first. So I know using a tape diagram that this is going to represent 3x, and this is going to represent 4y. Now we know we have to double it, so I'm going to have 2 of them. So I'm going to show my double. 3x, 4y. So now I've doubled it. So are there any terms we can rearrange and combine? Yes, so I know that I can rearrange this tape diagram to look like this. I can rearrange so my 3x's are together. I can rearrange so my 4y's are together. Now I can go ahead and start to combine. If I have 3x plus 3x, that's going to give me what? 6x. If I have 4y plus 4y, that's going to give me 8y. So, have you noticed the pattern? So when we get this, it's going to give me, as my answer, 3x plus 8y. How can we simplify the expression without drawing a model? Is that possible? What is the pattern? I want you to think about that. You're right. When there is a number outside the parentheses, I will multiply it by all the terms on the inside of the parentheses. Why do you think we might not always want to draw a model? So why do you think we might not always want to draw a model? Correct. It will take too long to draw a model, especially if we're multiplying by a larger number, like 14. We want to know how to apply this distributive property. The model kind of just helps us, especially with those smaller numbers. But when we get to those larger numbers, we might not want to draw one. So let's test our theories a little bit for our third example. I want you to draw a model for 2 times 2x plus 3y. So we're going to draw a model, and I'm going to write it on the board. For 2 times 2x plus 3y. Where do I start when I'm drawing my model? Correct, with my 2x and my 3y. So I know I have my 2x, my 3y. What does this mean again? That we're going to have to double this. So 2x and my 3y. Can I rearrange this anyway? I can. I can bring my x's together and my y's together to create two x 2x, 3y, 3y. So now that I can combine those, I know I have 2x plus 2x, which is going to give me 4x's. And then I have 3y plus 3y, which is going to give me what? You got it, 6y. So now here's my answer for my equivalent expression. 4x plus 6y is equivalent to 2 times 2x plus 3y. Kind of got that? All right, so you're doing great with this lesson. So we're going to I want you to jump into helping me. We're going to create some models for each expression. Then we're going to write another equivalent expression using distributive property. So I'm going to allow you some time to write down these problems. The first problem is going to be three times x plus y. All right, so I want you to go ahead and start drawing your model and rearranging and can combine and see what you get as your equivalent expression. All right, so I know I can start on the inside of my parentheses with my tape diagram using x plus y. I'm not doubling it this time, I'm tripling it. So it's going to be 3. I'm going to have to make sure I have x plus y 3 times. So here's x plus y. Here's another x plus y, and here's another x plus y. So now that I know that, I can start rearranging so I can start combining my like terms. So I'm going to rearrange to show all my x's together. Then I'm going to rearrange to show all my y's together. So now I can start combining my like terms. So I know that I have x plus x plus x. When I combine these, this is going to give me 3x. Plus, when I have y plus y plus y, when I combine these are going to give me 3y. So my answer, 3x plus 3y, which is equivalent to our original problem, which is 3 times x plus y. Yeah, that's pretty good, huh? Let's try another one. Let me erase my board. All right, so my next problem we're going to do, let me step it up a bit. So it's going to be 4 times 2h plus g. I want you to try using a model and then combining your like terms to get your answer. I'm going to give you a few minutes to try it out. All right, so let's try this out. If I have my tape diagram, remember, what do I know? I start with inside of my parentheses. So I know I have, starting off, I have 2h plus g. How many times should I have this 2h plus g? 4 times. So I know I already have it 1 time. but I need to have it 4 times. So let me do it 3 more times to get all 4 of them. 2HG, 2HG, 2HG. So this part represents 2H plus G. This part represents 2H plus G. And this part represents 2H plus G. Now I can start rearranging so I can combine my like terms. What do I want to put together first? Okay, we'll go with our 2H's. So I know I have 1, 2, 3, 4 2H's that I'm going to bring over. So 2H, 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 and I can cross them off if I need to so I can know that I've already used them. So now I'm going to bring my G's over, and I have 1, 2, 3, 4 G's I'm going to bring over. G, 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 and G. Now I'm ready to combine my like terms. How many 2H's do I have? Well, I have 1 2H, 2 2H, 3 2H, 4 2H's, but they all have a 2H in them. So this is a 2H plus a 2H plus a 2H plus a 2H. So that's 2H, 4H, 6H, 8H. See what I did there? Because this is already 2H's, so combining makes 4H's. Keep going, 6H's, 8H's to give me 8H. So next I'm gonna go with my G's. I have 1G, 2G, 3G, 4G. So my answer should be 8H plus 4G. Is that what you got? Great. So I'm going to give you a couple more problems that I want you to try on your own. You can choose if you want to use a model if needed. If not, you can just go ahead and combine your like terms to create that equivalent expression. So let me erase this. And here's your problems. The first one, I have 8 times H plus 3. Second one, 3 times 2Y plus 7. And my last one is going to be 4 times 11N plus 3M. I'm going to give you a couple minutes to try to solve this. Remember, when using a tape diagram, look back over what we've previously done. See if that helps. Also, think about the pattern that we found. So keep going. Let's look at the first one. Did you get, for your answer, 8H plus 24? If you did, great job. If you didn't, go back and look at your notes. See what you need to combine. Use that tape diagram if you need to. Make sure that you're combining those like terms. Keep going for the rest of the two. All right, so for this one, did you get 6y plus 21? You did? Great job. So my last one, did you get 44n plus what is it? 12m. You got it. So these are my equivalent expressions here. So great work. Today we reviewed ways to use distributive property to write equivalent expressions. I hope you're seeing the significance of using our properties to expand expressions. You sure did do a great job today. After the video, you will have some practice problems that you're gonna try on your own. Remember, go back over the notes that we just did today. Look at the previous problems. Use that tape diagram if you need to. Good luck, and I want you to do your best. Boys and girls, I've enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.
Hold on. You ready to have a snack? Yes?
More.
More? Okay.
More.
Let's count.
More.
1,
Three.
2,
Three.
3, 4,
5.
and 5. Want to eat one? Oh, go ahead. How many did you just eat? Did you just eat one? Okay. Let's count again. We got 1, 2, 3, 4.
5.
4. You just ate it.